Ship, avionics, power, and telemetry nominal. Field course.
All right, we're just a little over a minute
maximum
into flight.
Dynamic pressure.
We're about And so while we continue to watch it go up, a lot of our flight controllers looking at all the systems around the tower. Again, we have to send a manual command. Just about 30 seconds away from hot staging. And we heard the tower is go for catch.
Booster engine cutoff.
The return flag is set for true.
Ship engine startup. Stage separation.
All right, hot staging confirmed. 6 out of 6 lit on the ship. Booster boost back going. We heard that we are go for catch. Kate, Jesse, take at the views. Hopefully I got a booster coming home real soon.
Wow, from our view here, Dan, great views of planet Earth behind that super heavy booster. Right now it is performing the
Ship
boost back burn.
Nominal.
Good news there, telling us that the pressures inside the ship are good. That is the second stage or the upper portion of the vehicle. Follow along with the telemetry on the bottom of your screen.
Yeah, booster is currently, super heavy is currently in its boost back burn. This boost back burn.
Avionics, power, and telemetry nominal.
This boost back burn lasts just a little bit over a minute. So we've got a little, approximately 30 seconds left.
We've had shutdown of that boost back burn. Up next will be hot stage jettison. The view from the camera on the left, or from the booster on the left-hand side of your screen, and then tracking cam there on the right-hand side of your screen. We'll see those grid fins.
Booster offshore divert.
And we can also see that the hot stage has been jettisoned.
Yes, visual confirmation of that there on your screen, which is great. Now the next
Starship is following a nominal trajectory.
The next step for booster is going into that landing burn. Again, it'll light up 13 of those engines and then pare down to 3 engines right before booster catch.
All right, now just real quick, we did hear the call out, booster offshore divert. Unfortunately, that means that we are no-go for the catch. As we said before, both the tower and the vehicle, as well as the operators on console, have been actively evaluating the commit criteria for that return to the launch tower. And unfortunately, we did not have a pass on those commit criteria. So we are no-go for tower catch.
And we did mention that we're constantly evaluating the criteria for catch. There's a lot of things that need to go well in order to line that up. Unfortunately, today we will forego booster catch today, but what you're seeing on your screen is ship currently making its way towards the Indian Ocean, still looking good so far.
Exactly. So views there of the booster on the left-hand side of your screen, views of the ship on the right-hand side of your screen. Now, we said before that it was not guaranteed that we would be able to make a tower catch today. So while we were hoping for it, like we said, it was pretty epic on attempt 1, but the safety of the teams and the public and the pad itself are paramount. So we are accepting no compromises in any of those areas.
Exactly. And we're still going to get a lot of good flight data with booster even, but especially with ship. Again, we have an additional objective today to do an in-space relight of a Raptor engine, which again will help us set us up for being able to do deorbit burns, which is
Ship chamber pressures are nominal.
which is important for orbital flights. And what you're seeing on your screen is a view from Super Heavy as it's making its way back down to Earth.
Yeah, once again, we are attempting an offshore landing of the Super Heavy booster. So we have seen this before, and it is still very fun to watch, watching it come down for a soft splashdown off the Gulf Coast of Texas. We can see it there re-entering. We saw earlier those grid fins. There are 4 hypersonic fins. Oh, we can see that the landing burn has begun on the Super Heavy booster.
And same pattern, 13 engines will light, gone down to 3 just as we expected. And what an incredible view of splashdown that we got today of Super Heavy.
Yeah, I'm sure the buoy cam views will be pretty awesome once again. So we'd like to confirm a water landing once again for the Super Heavy booster. Congrats to the SpaceX team.
along. The flight path was cleared prior to launch, and we expect the road and beach to remain closed until further notice.
Yeah, testing development flight hardware in a flight environment is what enables our teams to quickly learn and execute design changes and hardware upgrades to improve the probability of success in the future. Please do not attempt to approach the booster in the water for your safety as well as for that of our team that will be working on recovery. Now, we are going to continue though. The mission is not done.
Exactly. The mission's not over. Ship is still coasting, but it has been nonstop since liftoff. And with the booster having completed its job for the day, we are going to take a short break for the next 35 minutes or so while ship continues to coast before reentry. Now, as with previous flights, Starlink may enable us to talk to the ship through reentry with no communication blackout. Now, we are still testing Starlink during this phase of flight, so nothing is completely certain.
Yeah, so if we do have views, we will be sure to bring those to you live. And of course, one of those views include that of our, as we said before, surprise payload, the banana. And we are looking forward to it. So we're going to come back in a few minutes, around T plus 35 minutes.
Exactly. Views or no views, we'll see you back here at T plus 40 minutes for our coverage of Starship's reentry, flip maneuver, landing burn, and hopefully see a splashdown. Missions to go to the moon or Mars or become tankers for refueling or any number of other uses, but the boosters will come back and turn around to launch the next ship. So in order to hit that production cadence of hundreds per year, we're rapidly building out Star Factory, which is our Starship production facility in Texas.
And views of that Star Factory there. Now, this place allows us to move system integration work earlier in the build process, which means more efficiency, higher quality, and ultimately faster production. Starbase is an incredible place to be right now. There really is nowhere else in the world like it. You know, hint, hint, nudge, nudge.
Now, what you might be hinting at is the good news is we are hiring. If you love what you're seeing, check out our openings at Starbase. On the engineering side, we're looking for vehicle design engineers across structures, propulsion, and integration.
And if you're a hands-on tech, we're looking for integration technicians and welders that can help us hit our goal of building a Starship every 8 hours. And to do that, we need builders.
Yeah, we're definitely going to need a lot of builders to get that down to just 8 hours.
Right? Now, beyond that, in order to keep Starbase growing, we have all kinds of roles, from baristas to HVAC technicians to EMTs. So chances are, if you're looking, we have a place for you. Visit spacex.com/careers to see all of our openings.
Every role is critical to the future of Starship. With Starbase growing faster than ever, we can't do it without you.
This place is where our future is being built, and that is a future that we are all very excited about. All right, let's dive deeper into the inner workings of Starship and learn more about this flying skyscraper.
Starship features two major parts, the ship, which has 6 Raptor engines, and the Super Heavy booster, which has 33 Raptor engines. Now, just like flights 1 through 5, the current iteration of Starship is an experimental vehicle flying for development. And with a few planned upgrades, Starship will have 3 times the thrust of Saturn V at 10,000 metric tons of thrust, plus the added benefit of full reusability.
Space Monkey. Oh, okay. I thought you said Spice Monkey.
Sorry,
Yeah. No, no.
I volunteer.
Yeah. No Space Monkeys. We'll make sure it works with cargo, and then we'll add people. Hey, is it? Can we do that? We should go do the tour, or they're going to. You're ready to get to it? Yes, look at the factory. Yes, sir. All right, so we can go look at the factory and then come back and see the lab, the ship landings. Right. Great. That's really cool. Yeah. Yeah. So we're wearing a jacket on this web, I guess. The core.
On a flight day, you got to wear a jacket.
Yeah.
I'm Bryson. Bill, pleasure. Very good.
Can I go over on the other side? Yeah. Because of the sun?
Yes, that's fine.
Atmospheric flight and enable a precision landing.
To reach full reusability, the ship must survive reentry not just once, but multiple times. It took the teams at SpaceX about 3 years to develop the heat shield on Starship, and development for improvements is still ongoing. The ship's heat shield is composed of thousands of hexagonal ceramic tiles designed to insulate the vehicle during atmospheric entry, where temperatures can be as high as 2,600 degrees Fahrenheit or over 1,400 degrees Celsius. The tiles are something we iterate on every flight test as we build towards a heat shield requiring no refurbishment between flights to unlock rapid reuse.
And the teams have actually already begun testing the heat shield tiles in environments simulating Mars atmospheric entry conditions, which we'll see more of in just a few minutes. You know, slightly different than coming back to Earth.
just slightly different. And in between the first and second stages is our hot stage, which we saw in action on flights 2, 3, 4, and 5. So let's recap that last flight to understand what we accomplished and how that's changing for today's flight.
On October 13th, Starship successfully lifted off at 7:25 a.m. Central Time from Starbase, Texas. A gorgeous sunrise ascent that was fairly quickly followed by the hot stage separation maneuver, which we see here, as well as on multiple previous Starship flights. The booster then performed a flip maneuver, boost back burn, and then we jettisoned that hot stage, which you see there. The booster then performed its boost back burn, which brought it back on a trajectory to the launch tower, back to the Gulf Coast. We can see here the booster descending through the Earth's atmosphere. It broke the sound barrier again as it was coming back through. Those Raptor engines relit, and then the moment that made us all lose our minds, the booster came back for a successful first ever catch by the chopstick arms back at the exact same launch tower that it launched from. It was insane. As you can see, we all went bananas. And you did too, probably. Thousands of
during final descent. This one knows the limits of the flap's ability to maintain control but it will be a chance to get real flight data on what our limits actually are.
So, to put it as bluntly as possible, do not be surprised if this is not a smooth flight to splashdown today. We are intentionally looking for how far we can push and discover the vehicle's true limits as we plan for future ship return and catch.
And even though ship recovery is not expected today, the telemetry and data we receive all the way to the end is what we're looking for and what will help us get to a rapidly reusable Starship of the future.
Now, just like Flight 5, one of our objectives for Flight 6 is attempting to return the booster to the launch site to be caught by the tower. The booster for this flight has upgrades to add redundancy across its propulsion system, increase the structural, as well as increasing the structural strength in a few spots. We've also implemented a few changes across both ship and tower to try and speed up the post-catch timeline. Returning vehicles to the launch site leverages the same hardware that we use for stacking ahead of flight, making our infrastructure multi-purpose. And in order for us to achieve that rapid reusability that we keep talking about, we need a quick turnaround. And you can't get much faster than returning the launch vehicle right back there to where it needs to launch from again.
Exactly. In this video, you can see our original render of booster catch alongside the actual footage of catch from Flight 5. This video is just mind-blowing to see the predicted versus reality. And just like the last flight for today's booster catch, there are thousands of criteria that need to be met in order to proceed with catch. Automated checks have to indicate we have a healthy booster and a healthy tower, and the flight director must issue a manual command, which is informed by manual checks from the flight control team. If this command is not sent prior to the completion of the boost back burn, or if automated health checks show unacceptable conditions with Super Heavy or the tower, the booster will default to a trajectory that takes it to a landing burn and soft splashdown in the Gulf of Mexico.
I remember when we first heard the call out that tower was go for catch on Flight 5, and wow, I still get goosebumps when I think about that moment. Now, for today's test, just like Flight 5, we're only going to catch if everything on the booster and the tower checks out after launch. As always, we accept no compromises when it comes to the safety of the public and our team. And so to that end, the area around the pad and the flight path are cleared in advance.
A lot of things have to go right in order to line up the booster catch. So if all criteria is met, we will attempt the catch, but there is a chance that we may not. Either way, we'll be getting tons of in-flight data, which is extremely valuable.
Exactly. That first catch was pretty epic, though. So like you, we'll be keeping our hopes high to see another one this afternoon. Now, Dan, you got to see it in person last time. Are you mentally prepared for a possible round two?
I mean, probably not. That was pretty hands down the coolest thing I've ever seen. And the fact that we're going to do that every time now breaks my brain a little bit, but it was absolutely incredible. One of the unique aspects with Super Heavy coming back is it does generate a sonic boom. This is something commonly associated with reusable spacecraft. It's coming in faster than the speed of sound and then slowing down. It creates that pressure wave that builds up. And then when it reaches you on the ground, that rapid change in pressure is that quick thunderclap sound that you hear. Now, generally the only effect is that thunderclap.
You go through the whole East Coast.
These first flight tests to Mars will be test the reliability of landing in tech. If those landings go well, the first crewed flights will soon follow after that.
Right now, our flight tests are focused on proving out reusability of both Super Heavy and Starship. In 2025, we'll continue that focus while also potentially flying our first Starlink missions and demonstrate capabilities central to our role in taking astronauts to the moon as part of NASA's Artemis program. Starship will be used to land astronauts on the lunar surface on NASA's Artemis 3 mission, which will put the first humans on the moon since 1972.
One key capability will be the ability to refuel Starship on orbit, which you can see there on your screen, with a Starship prop tanker docked with a fuel depot. Next year, we're planning to test this capability by launching 2 Starships and having them meet up to transfer tons of cryogenic propellants. Now, when the time comes to land on the moon, Starship will link up with NASA's Orion spacecraft in lunar orbit, where astronauts will transfer over for their descent. Now, once on the lunar surface, they'll ride the elevator down in their Axiom EMU spacesuits from Axiom Space and leave the first footprints on the moon in more than half a century, kickstarting humanity's mission to establish a sustainable presence there. And coming soon to a moon base alpha near you, Starship Enterprise Edition.
That is so exciting, and all the advancements that are going to come in order to enable all of that. Now, our rapid iterative development approach has been the basis for all of SpaceX's major innovative advancements, including Falcon, Dragon, and Starlink. Today, we're testing hardware and systems, and we need to know how they perform under the most extreme conditions. And what's more extreme than the flight environment? We'd much rather find the bugs and limits now during testing than later on when there's more on the line.
And to reiterate, while we do determine an acceptable level of technical risk on our vehicle and pad to learn as fast as possible, we accept no compromises when it comes to the safety of the public or our team. So all that to say, this is only the 6th of many future flight tests of Starship before it becomes fully operational.
And we tend to do our testing out in the open, just like today. And that means people sometimes see when our hardware doesn't perform as we planned during that testing. And that's okay, because this is exactly what we are testing for, to physically see if hardware performance matches what we expect it to do or not. Even more with today's test flight, where we're purposefully pushing the ship beyond its limits.
Starship development is also being aided by Starlink space-based connectivity. You might remember the Starlink panels that are incorporated into Starship, and you can see them there on your screen, those rectangular panels on Starship